Here are two more very capable rubber powered stick and tissue free flight model airplanes I built. Wally Simmer's Golly Walk and Crine Laffler's Bluefin P30. What is the fascination with model airplanes like these? I truly feel like this is an art form. The building and flying of free flight model airplanes. The other aspect of it is the history. These are some of the very first model airplanes that were built by young boys that were coming up with their own designs and competing in what was called the postal contests. That was contests that were sponsored by some major corporations in this country in the mid-1900s, and they would compete in the various area codes and they would mail in the results. So hence the postal contests. Eventually there were classes of models formed, and the winners out of the different area codes would go on and compete in national contests. Still today, anybody that gets involved with this gets that same satisfaction of creating something, scratch building something, and then the joy of flying it. All of the stuff that is involved with these airplanes, from the plane itself to the support equipment, is stuff that you fabricate, ideas you have, and then you make it from all the various materials. Every one of these planes has a time that it will fly in what's called dead air. So you have your climb phase and your glide phase, and then the magic happens when you catch a thermal. I can't help but think about and marvel at some of these designs that came from these young boys that were creating things, designing things, and scratch building them just from materials they had laying around, or they would, I'm sure, spend their allowance money going to a local hobby shop and buying balsa wood and tissue and rubber and props and going home and designing and building these airplanes. Here is my Golly Walk set up in my stooge. So it has a folder with the spring set up, adjustable nose block. It's got stop screw. I'm using what I call a wing loop on here. So it's one rubber band, 3/16 rubber band goes around the wing, around the fuselage. What this is a bead on a fishing line, and you peg it, put a knot in the fishing line, then you peg it with a piece of wood and super glue it. This guide here is actually the stop for how far the thermalizer trips. In other words, the angle that we'll end up with on the horizontal stabilizer. So the bead stops against that guide tube. It's a guide tube and a stop, and that sets the angle on your horizontal stabilizer. On this one, it's a piece of wire with a rubber band going around the fuselage that gives the spring tension for the dethermalizer. This also is adjustable rudder with that screw, but in this case I have these two pins in here and a small rubber band, so it just holds it against that screw. So it's a right climb, left glide. See how the horizontal stabilizer is tilted? So it's a lifting stabilizer. In the glide, with this tilted, it lifts the rear of the plane to the right, so it glides to the left. Here is another idea of mine for adjustments on the horizontal stabilizer. Have that little piece of aluminum with the screw in there, and the horizontal stabilizer is setting on that little plywood strip. So here's the blast tube or blow tube. Something I didn't point out in my last video is the notches on the blow tube. This also has an open bay back at the rear peg. So the notches on the blast tube, you can see it just coming back here. It snaps on to the rear peg, which gives you complete protection from a rubber motor blowing up inside the plane. And here's the blast tube hanging out the front of the Golly Walk. So here's that fabricating, creating by hand. On this one, I started with a bought machine carved prop. I had to cut the profile. I think it just came straight out. Sand the leading edge, radius the leading edge. Fabricate the hinge, do the whipping, and then make these cuts. So now when it folds back against the plane, the blades are as flat as you can get them to the fuselage. And in here, like this is music wire. So you're playing with the diameter of the music wire and the length of these legs, and then it has one coil. So that's how you're calibrating, if you will, the spring tension for the rubber motor. So you're cutting the length of this copper tube, putting the washers in there, so when the rubber motor pulls that back, and then this part of the motor hook has to clear the stop screw. So you can see all the way compressed, it's just clearing that stop screw by a little bit. As it's unwinding, the tension's coming off, it starts clicking against the spring, eventually it just catches it, stops and folds it. So the nose block, you're gluing layers of balsa wood together, and I've alternated the grain 90 degrees to get that striped appearance. You're carving that, sanding that. Made up the plate on the back with the crosshairs and the marks on the plate. So you can see this has a fair amount of down and right thrust. Fun stuff fabricating this. Then I put a mark, I put a dot on the top because I believe I could reverse this, put it upside down, and I would not have down and right thrust. So I have to keep that orientation. Looking at my notes on the Golly Walk, airframe's 3.5 ounces. It's got a 31-inch wingspan running a 13.5-inch folder. This is a right climb, left glide model. Here are the makeup of the rubber motors that I've flown in contests. Here I have documented my torque, 45 ounces, about 825 winds. And nice thing, when you go by torque, you get the same response in the model as far as your down and right thrust, because you're running the same amount of torque. You have differences in the rubber, and also you don't have to count winds. Here is one of my homemade torque meters. So you use different lengths and diameters of music wire. So that's just a piece of wire going through with a loop on each end, and it's inside this brass tube, and it's soldered on this end. I have this plate soldered on the brass tube, and then I have a needle soldered onto the music wire. So these are calibrated torque meters. I just put the marks on them in inch ounces. These two are the same size wire but different lengths. So this reads from 0 to 25 inch ounces, and this one with a longer wire has a finer resolution. This reads from 0 to 15 inch ounces due to the length of the wire. And then this one is shorter and thicker wire to get up to my 45 inch ounces. Looking at the Crockett hooks, as I explained in my other video, you have the two holes for transferring using the wire in this hole to control the wound rubber motor, and then transferring it from the winder to the wire hook to put your blast tube on and off, and also to transfer onto the nose block, the hook on the prop shaft. But so there's that, and then the feature of the rubber motor not being able to climb off the hook. So there's no way it's happening with this hook design, and this is also for handling big motors. So you're splitting up your strands on both sides with the motor for beautiful bass. But here's a conventional Crockett hook. So it just looks like a hook. But you can see the shapes they have in there. Like there's a bit of a lip right here. So the torque is going to be that way. So that lip keeps it from climbing off the hook. So this is a bought Crockett hook, and so are these. So this one I bought for Beautiful Best, and I bought these. And then these are two of them that I made. So I just cut them out of aluminum and followed them up. Bought ones, handmade ones. So I just cut them out, and you can see I've like followed that lip on there. Got two holes. Same with this one. See the shape in there to prevent the climbing of the rubber. This is my winder. So something really important to show here. Don't put a piece of wire with a hook bent on it in a drill chuck without a safety loop. So you can see how I have, this is wrapped with copper wire and soldered, and I have this safety loop going behind the drill chuck. So even if this came loose, this can't come flying out. It's captured behind the drill chuck. So just things you make up for your field kit support. Taking a look at the Klein Laffler designed Bluefin P30. It's in the name, it's a class of plane, P30 class. So can't have more than a 30-inch wingspan. I think it's 10 grams of rubber, and this uses a plastic prop. On the nose cone for down and right thrust, it's a simple matter of sanding the angle on the tube fuselage. Fuselage is rolled balsa tubing. So we have the angle for right thrust sanded on the end of that tube, and down thrust. This was an interesting building concept. You soak sheets of balsa, it's a couple layers, get it wet, and you wrap it around the dowel of the right size, let it dry, glue the seam on the bottom, back section from the rear peg on back is a tapered tube. I've removed the wing to show you the pylon, the wing pylon. Look in here for adjusting the wing forward and back for changing the center of gravity. Instead of gluing it in place, I have those slots down in there on the bottom with nylon screws. Here is a simple but fascinating idea for a timer, a dethermalizing timer. This piece of aluminum tube right here is called a snuffing tube. Use this slow burning fuse. Burns at about the rate of 1 inch a minute. Here it is set up with a piece of fuse in there to demonstrate it. You set your length of fuse for the length of flight that you want your dethermalizer to trip at. Light your fuse before you launch it. It burns down, burns through the rubber band. The rubber band burns through. Your dethermalizer pops up. The thread, length of that thread sets your angle. And these rubber bands up here provide your spring action. So there is a bit of a look at scratch building free flight model airplanes. And then there is blueprints, or should I say blueprint collection. It's what it becomes. This is a box of ideas, really, of planes that you might build someday. If you can scratch build and they make a blueprint, you can make that airplane.